All right, we're going to go ahead and get into the next section of notes for this unit here. So this is going to be 7.3, and we're talking about tests for parallelograms. Okay, so the date that we did this is the 4th, and our objective for today is we want to be able to use what we've talked about with parallelograms to make sure that we could prove is the shape or is the quadrilateral I'm looking at a parallelogram. Okay, and that's going to have to deal with a little bit of proofs, but really just in general understanding these theorems. So first off, a little review. Do we remember what we talked about last time? What is a parallelogram? Okay, so as a reminder, a parallelogram here is a quadrilateral. Okay, a quadrilateral whose opposite sides are parallel, as the name would suggest, to each other. Okay, a quadrilateral whose opposite sides are parallel to each other. And we drew examples with this, and we said, okay, once we know that this is a parallelogram, we know all of this information here. Okay, as I mentioned, today our goal is to not use those pieces of information, but be able to show in general, before we're told anything, or before we're told all the information, that it is in fact a parallelogram. And so to be able to say that, or to be able to prove that, we have a few different theorems that we're going to go through. These theorems aren't like you usually see where, we have a name for it, like the triangle inequality theorem or something like, or, side angle side or something like that. These, we'll just number them because we don't really have any specific names for them. So first one, since we're in Unit 7, we'll just say these are Theorem 7 and then 7.1. So Theorem 7.1 says this. It says if both pairs of opposite sides of a of a quadrilateral, I should say, because that's going to be our end goal. Okay, if both pairs of opposite sides of a quadrilateral are congruent, then what I can say is I'm going to have the same conclusion for all of these. Then I can say, then it is a parallelogram. So we're looking at a shape. If we just see that both pairs of opposite sides are congruent, then I can say it's a parallelogram. So for example here, if I draw this in, notice we don't have to be told that they're parallel. If we were told that they're parallel, then it would already match the definition and we're good. But if we're not, if we're told that the opposite sides are congruent to each other, both pairs, not just one of them, then we can say that this is a parallelogram. Okay? Leads us to 7.2. Similar kind of idea, except with the angles here. And this is going to kind of be based off of the information that we talked about in the last lesson. I can say this. I say if both pairs of opposite angles, okay, of a quadrilateral, it does need to be a four-sided shape, otherwise obviously it wouldn't be a parallelogram. So if I look and I see the same kind of idea with the angles, and I say that they are congruent, just like we talked about last time, then same thing applies, then it is a parallelogram. So notice we're kind of using the information that we talked about in the last lesson, except in the reverse order. Last lesson we said this is a parallelogram, now I know information. This time we're saying here's the little pieces of information, now I know it's a parallelogram. So again, if I want to draw a little example with this, we can draw this. And I want the opposite angles to be congruent. So for example, we could put one arc here and then two arcs here. Okay? All right, moving right along, we have a couple other theorems that help us out as well. Again, 7.3 comes from one of the things we talked about last class. I could say if the diagonals of a quadrilateral bisect each other, if the diagonals of a quadrilateral bisect each other, then, same kind of idea, then I can say it is a parallelogram. So we talked about that as a piece of information. Now we could use that information to say that the shape I'm looking at is a parallelogram. So what did that look like here when we talked about it yesterday or in the last notes? I'll go ahead and draw a quadrilateral. I'll have the diagonals here, and we want them to bisect each other. So for example, that means these two segments would be congruent here, and these two segments would be congruent here as well. Okay, so this is theorem 7.3. If I see a picture that matches this, and remember it has to be both diagonals, not just one of them, then I can say that it is a parallelogram. All right, and then last one here, 7.4, rounding everything out. I know this is a good amount of writing. Theorem 7.4 says this. It says if one pair of sides, so now not both, but if one pair of opposite sides of a quadrilateral are, and we're going to say two things. Let's say first off, what if, or they have to be parallel. So switching it up this time, let's say if one pair of opposite sides of a quadrilateral are parallel and congruent, if I can show both those things, or if I have both those things, then same conclusion as before, then it is a parallelogram. Okay, so this time we're not talking about both pairs of sides. This one's kind of unique, or it's kind of a mix of a couple things that we talked about in last class. But let's say we just have a shape here, and we just choose one pair of opposite sides. So for example, these two here, they would both need to be congruent, and they would need to be, and I'll try to draw a better arrow than that. Okay, they would also need to be parallel as well. So if I can show that, or if I'm told that information, then that is enough to say that it's a parallelogram. Okay, so really it's just using these four different theorems and seeing if these match up. In general, we're not gonna, I'm not gonna expect you to memorize these or which one matches up with which. As long as you know how to find these in your notes and can apply them to the problems that we're gonna work on, that's all I really care about. Okay, so with that in mind, let's practice this a little bit. So for example, one, I want you to draw these two shapes for me. And notice here the big difference from today and yesterday, or last notes I should say, is that we're not told from the start that these are parallelograms. And in fact, that's going to be our goal. We're going to try to figure out, are these parallelograms here? So for example here, the first one, I want to determine if this is a parallelogram, and then if it is, I want to say the theorem that it matches here. So I look at this, I see I have one pair of opposite sides that are congruent, they're both 5, and then same thing here with another pair of opposite sides as well. So since both these pairs of sides are congruent here, what I can say is this a parallelogram? Yes, it is a parallelogram. I could write that whole thing out if I wanted to. And then the other question is, what theorem does this match? Well, we see that both pairs of opposite sides are congruent, and so that matches 7.1 that we talked about earlier. This would match the 7.1 theorem. Okay? Using that same idea with the second one here, if I'm looking at this picture, I see I have one pair of congruent sides that's already marked for me, and I see I have one pair of congruent angles here. And if this is the case, is this enough to say that this is a parallelogram? Well, I can kind of scroll up here and see, does this match any of my theorems? First one only has to do with sides, second one only has to do with angles, and third and fourth one don't have to do with angles at all. So in this case, this would be no. This does not match any of our theorems. This is a mix of some of our theorems. I see one pair of sides and I see one pair of angles, but I would also need the other pair of sides or the other pair of angles in order to say that this is a parallelogram. So simple enough, I can just say no here. Okay? All right, moving on to another kind of problem. How could we use this in proofs? And this one's going to be kind of unique. We're going to use things that we talked about before, and we're going to actually prove the theorem, one of the theorems that we just wrote down, and prove why it works or why we can use it. Okay, so you can take a second and you can sketch this shape for me here. And then I'll go ahead, once you're done sketching, you can go ahead and set up your proof. Okay, statements and reasons. Okay, first reason here, you can go ahead and say given. We know the drill, so I can just go ahead and copy everything down. So I can say AE is congruent to CE, and then DE is congruent to BE. Okay, so just rewriting all of the given information here. Okay, now if this is the case, if I want to use this here, I notice at the end I want to prove that this is a parallelogram. Now if it didn't tell us to prove this theorem, we could just use 7.3 theorem and we'd be done. This matches one of the theorems we've already written down. But since we're trying to prove it, we're trying to show that it works in some other way. And so what we're going to do here is we're going to use ideas that we've talked about last chapter with triangle congruence. So if we look at this, we've seen this kind of diagram a lot in Unit 6. We see two pairs of congruent sides here, and then if I ask you what other information do you know just by looking at the diagram here, we'll notice we can see vertical angles here at angle E. So that's exactly what I'm going to say. Is I'm going to say angle, and we'll name it AED, is congruent to angle, I'm going to make sure to order these correctly, angle CEB. Remember, that's just going back to our strategies that we talked about last unit. What do I know for my given? What do I know for my diagram? And my reason for that, like we just discussed, these are vertical angles, so that's going to be the vertical angles theorem. Okay, so this is my first step. I've just used what I know from the diagram. Okay, now that I have this is helpful for us because I do have enough information here to prove that these two triangles right here are congruent. And so I'm going to do that because that's going to help me as I eventually get to my end goal of proving that this is a parallelogram, because I want to match one of my other theorems here. So I'm going to say triangle AED is congruent to triangle CEB. Okay, I have enough information there that does match one of the theorems from last time. And remember, we've seen this before. This is what would be side angle side theorem. Okay, side angle side theorem. Okay, why did we do this, or why did we go back to proving that these were triangles? Because really we want to prove that this is a parallelogram at the end. Well, notice we've said this before. Now that I've proven that these are congruent triangles, all of their corresponding pieces are fair game. And so something that's going to help us here, some of their pieces that are fair game, are the third set of sides that we haven't talked about yet. So I now know by CPCTC that those third set of sides are going to be congruent. And so I'm going to go ahead and say that. I can say side length AD is congruent to side length CB. And what is my reason for that? CPCTC. Okay, so all of this work to say we've just proven that those two opposite side lengths, AD and CB, are congruent. And this is helpful because if this is the case, if we do the same thing with our other pairs of sides, AB and CD, if I can do that, then this will match our 7.1 theorem. I'll have shown that the opposite sides are congruent, and so this would be a parallelogram. So I'm going to do the exact same kind of process here, except with other two triangles. So for example here, I see these are also vertical angles. So I'm going to say angle AEB is congruent to angle CED, excuse me. Okay, and the reason is going to be the same. This is the vertical angles theorem. So I'm just doing the same kind of process, except now with the triangles on the top and on the bottom. And this is helpful because this is going to give me the other pairs of sides in this quadrilateral that can match one of my theorems. So we have this here. We've said vertical angles. That is enough information to prove that those triangles are congruent. So I'm going to say triangle AEB is congruent to triangle CED. Okay, I do have enough information that does match. That is also, like we've seen before, the side angle side theorem. Okay, now that we've proven that those triangles are congruent, this is helpful because that means all of the corresponding parts are now fair game. So there's another pair of sides that we did not mention in the proof that I can now say are congruent. So I'm going to go ahead and say that. I can say side length AB is congruent to side length CD. And my reason for that here, simple enough, is just going to be CPCTC. The triangles themselves are congruent, and so all the little parts that are in the same spot are congruent. And now if I look at this picture, if I just disregard the initial information I was given, I've now shown that I have, I've now shown that I have the opposite pairs of sides of this quadrilateral are congruent. So if that is the case, that does match one of our theorems. So I can go ahead and say my final statement that I'm trying to prove, ABCD is a parallelogram. And then what is my reasoning for that? Well, remember, this matches that first theorem that we talked about, and if I don't remember it, that's okay. I can just double check from the ones that we wrote. I show that the opposite sides are congruent. So this would match 7.1 theorem. Okay, so this is the idea. You can use some things that we've talked about in the past to prove new theorems that you can use as we work through these different problems. Okay, one more example here. Another way that we can use this idea, a little bit simpler of a way, is if we're looking at a graph. So this will be example 3. I want you to take a sec and I want you to sketch this quadrilateral for me here and sketch this graph. So let's say we're looking at this graph and it says I want to use the coordinates to determine whether this is a parallelogram. So what I'm going to do here is I'm going to do this actually in a variety of ways because you guys will see both types on your homework here. So if I'm looking at this and I want to prove that this is a parallelogram, remember we have multiple theorems that we could use to do that. We have one involving angles, and we haven't really talked about how we can find angles on a graph, so that's not going to really apply here. And then we've talked about other ideas as well. The one that would be simplest, though, is not even one of our theorems, but just the definition of a parallelogram. Because remember, we said if it's a parallelogram, that means that the opposite sides are parallel. So if I can show that KL, for instance, is parallel to NM, and then same thing, if I can show NK and ML are parallel, then I can say that this is a parallelogram. And this is a little bit easier because I don't have to find the distance, I don't have to use too many complicated formulas. I can just find the slopes of these lines. And if the slopes are the same, then the lines are going to be parallel, like we've discussed a while back. Okay, so for instance, if I'm looking at KL here, let's start with KL. Okay, one way that we can find the slope of this line is just using the slope formula. So I want to use this just for the first pair because I want to show you guys that this is a possible way to do this problem. And this is something that you'll need slope formula there. Okay, one way that you can do this problem. So the slope formula there, as a reminder, slope formula is another way of rewriting rise over run. It is y2 minus y1 over x2 minus x1. So if I'm looking at this here, k is at the coordinate point 2, 3, and then L is at the coordinate point, let's count it out, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Okay, so if I want to find the slope of KL, let's go ahead and write this out first. All I need to do is I need to use the slope formula and plug these in. So for instance, y2 would go first, so that would be 4 minus y1, which is 3. So I have 4 minus 3 on top, and on the bottom I have x2, which is 8, minus x1, which is 2. And now all I need to do is subtract these and simplify it. So I have 4 minus 3 on the top, that's just 1, and then 8 minus 2 on the bottom, and that is 6. So the slope of KL is 1 over 6. If I can show that NM has the same slope, then I'll have one pair of parallel sides. So that's exactly what I'm going to do. I'm going to do slope of NM, and I'm going to do the same thing. I'm going to use the slope formula here. So if I look at n is at the point 1, negative 3, and then m is at the point, let's count it out, 2, 3, 4, 5, 6, 7, negative 2. So I have 1, negative 3, 7, negative 2. Again, I'm going to plug these in. So I have y2, which is negative 2 here, minus y1, which in this case is negative 3, so negative 2 minus negative 3, and then all over x2, which is 7, minus x1, which is 1. Okay, so if I'm looking at this here, we'll test it out. I have negative 2 minus negative 3. Remember, minus and negative is the same thing as just adding. So this is really like negative 2 plus 3, which is positive 1. Okay, and then here I have 7 minus 1, that's going to give me 6. So this is good. I see the slopes of these lines are the same. They both come out to 1 over 6. And so I can say that I have one pair of parallel lines right here. Okay, I know KL and M are parallel. Now I need to do the same thing with N and K. Okay, in this one we're going to do a little bit simpler for the other pairs of sides. So next line I'm going to look at is slope of NK. And other than using the slope formula, because the slope formula is helpful if I'm just given the coordinates, but if I have the graph in front of me as well, what I can do is I can just do rise over run here. So for example, if I'm going from N to K, I can do the rise. So the rise is 1, 2, 3, 4, 5, 6. So 6 over 1. So it'd be 6 over 1, and if I simplify that, my slope is 6 here. Now all I need to do is check and see if ML is the same way, and if it is, then I can say that this is a parallelogram. So again, my slope, rise over run, so go up 1, 2, 3, 4, 5, 6, and then over 1. So slope of ML is going to be the same thing. I have 6 over 1, which is just 6. So those do check out as well. Those are both the same, which means those two lines are also parallel. Okay, so it's just asking, is this a parallelogram, or could you show that this is a parallelogram? This would be all the work that you need to show. You just need to show that these two lines are parallel, and then these two lines are parallel here. So like I mentioned, we did this two ways, because if you're given the graph, just use rise over run. That's simpler, right? But if you're just given the coordinates, it's a lot more helpful to use the slope formula. Okay, so just keep those ideas in mind. Okay, so many different ways that we can see different problems here. Assignment for today is going to be 7.3, test for parallelograms, and we're going to be using all of those ideas on those problems here. Okay, so rest of the time working on that, and if you guys have any questions, feel free to let me know. All right, thanks guys.